Where does the sun get its light from? This is a question humans have pondered for centuries. Unlike a bonfire, which needs fuel like wood, the sun has a different power source. It's not burning anything in the traditional sense. The sun shines because of a process called nuclear fusion. This takes place deep within its core, where the pressure and temperature are unimaginable. Imagine the sun as a giant pressure cooker. At its center, hydrogen atoms are constantly colliding. These collisions are so powerful that they fuse together. This fusion creates a new element, helium. The process releases an incredible amount of energy in the form of light and heat. This is what makes the sun shine. Fusion is not something we experience daily on Earth. It requires extreme conditions found only in stars like our sun. Think about trying to push two magnets together with the same poles facing each other. They resist. That's kind of how hydrogen atoms behave at normal temperatures. But in the sun's core, the pressure and heat overcome this resistance. The hydrogen atoms are forced to merge, forming helium and releasing energy. It's like those magnets suddenly snapping together, releasing a burst of energy. This energy is what powers the sun. Now, how does this fusion process actually create energy? This is where Albert Einstein comes in. His famous equation, E equals mc squared, explains it all. This elegant formula tells us that energy is equal to mass multiplied by the speed of light squared. This equation reveals that mass and energy are interchangeable. During fusion in the sun's core, a tiny amount of mass is lost when hydrogen converts to helium. This mass doesn't just disappear, it gets converted into a tremendous amount of energy, which powers the sun's light and heat. The energy created in the sun's core doesn't just radiate out instantly. It embarks on a long, arduous journey to the surface. The energy bounces around in a region called the radiative zone. Imagine a photon, a tiny packet of light, trying to navigate a crowded room. It bumps into other particles, constantly changing direction. After hundreds of thousands of years, the energy finally reaches the convective zone. Here, it's like riding on a boiling pot of water. Hot plasma rises, cools, and sinks back down, carrying the energy along. Finally, it bursts free from the sun's surface, called the photosphere, as sunlight. Once the sunlight leaves the sun, it travels through the vastness of space at the speed of light. That's about 186,282 miles per second. Even at this incredible speed, it takes time for sunlight to reach us. The average distance between the sun and Earth is 93 million miles. It takes approximately 8 minutes and 20 seconds for sunlight to travel this distance. That means the sunlight we see right now is actually from the sun's past, not its present. The sun is a fascinating celestial object. It's a giant ball of plasma, mostly hydrogen and helium. Its diameter is about 865,000 miles, more than 100 times wider than Earth. It's so large that over 1 million Earths could fit inside it. The sun is about 4.6 billion years old, roughly middle-aged for a star. But the sun is more than just a fascinating object in the sky. It's the reason for life on Earth. It provides the light and warmth that plants need for photosynthesis, the process that forms the base of our food chain. The sun drives our weather patterns, ocean currents, and climate. Without the sun, our planet would be a frozen, lifeless rock. The sun, our very own star, is a testament to the immense power of nuclear fusion. It's a constant reminder that we are part of a vast and dynamic cosmos, and it underscores the importance of understanding the universe around us, for it holds the keys to our past, present, and future.